Hi everyone, welcome to the session. I am Subrahmanya R Sharma, Assistant Professor, Department of Civil Engineering, SDM Institute of Technology, Ujjire. In today's session, we will discuss regarding soil phase diagram and basic relationships. Before proceeding with that, in this image, you can see a structure is partially tilted, or I can tell one side of a structure is settled. You can see it is a 3-story building. One side of this particular structure or a building is settled. What might be the reason? And also you can see here nearby of this particular structure a small canal where water is flowing. Okay. The reason behind this may be there is no proper investigation of soil might have done before construction of this building. And also we might have seen this particular image where some portion of the earth is sunk. Similarly, it is a usual thing. Okay, a constructed road is partially eroded, and also you might have seen again uneven settlement of basement story. And if you see these images or these things in daily life, it is very clear that before construction of any structure, there should be a proper investigation or proper test on the soil depending on the structure. And for that, I will define the phase diagram. And before that, I need to define what you mean by soil. In simple civil engineering way, the soil is defined as the unconsolidated natural material consisting of solid particle along with voids that may be filled with water, air or both, which lies above the bedrock and forms the foundation for civil engineering structure. And this definition holds good as in civil engineering aspects. Now, if you look into this particular soil, I can relate this soil to a sponge, okay, where in this particular sponge you can see a solid particle as well as the voids. Similarly, same thing, I am going to dip this particular sponge into a water and I will take it out at an instant. Now, we can tell we have a solid particle and also we have voids, and these voids are partially filled with the air as well as partially filled with the water. Now, the same case will happen in the case of soil also. And if you take the soil, the part of a soil will be filled with or voids of a soil partially filled with air and partially filled with the water. So, the diagrammatic representation of the different phases in the soil mass is called a phase diagram. So, in 3-phase system, it is composed of solids, liquids and gaseous matter or gaseous phases. Now, this is I can tell a microscopic structure of a soil. Okay. In this particular soil, as I mentioned, we have solid particle, we have some part will be filled with the water or some voids will be filled with the water, some voids will be filled with the air. The thing is, for the geotechnical analysis or analysis concerned to civil engineering, it is very difficult to analyze this system. Rather than we will do, if we separate all the solid particles in one, and again if you separate all the water in one, and if you separate all the air in one, the diagram looks like this. We have only solids and say water and air, and this diagram is a purely conceptual, but all the calculations, all the analysis, all the basic definition on civil engineering structure are depending on this basic conceptual 3-phase diagram. The 3-phase names comes, we have 3 phases of soil: solids, water and air. Now, same thing as already mentioned, these phases are named as we have a solid. So, corresponding to solid, this much volume of solid we have, and corresponding the weight of solid will be represented as Ws, corresponding volume will be represented as Vs, volume of solids. And again, if you come to water, we have volume of water here, this much is a volume of water, and similarly this much part is or corresponding weight of water is WW, weight of water. And coming to the third phase, air, this is a volume of air, this much volume is a volume of air, and corresponding weight is weight of air. And usually for the calculation purpose, weight of air, it will be in small quantity, it will be neglected, that is why I have written it as 0. Now, total volume is nothing but volume of solids plus volume of water plus volume of air. And also we have one more definition, so called volume of voids. Okay, as I already mentioned, it is a partially filled with water, partially filled with air. So, volume of voids is nothing but volume of air plus volume of water. Similarly, total weight equal to weight of solids, weight of water and weight of air. And again, I already mentioned, weight of air usually neglected. And this is the case partially saturated soil. Why the partially saturated soil is the voids, so called complete voids, partially filled with the water and partially filled with the air, and that is why the name partially saturated soil. And only in this case of partially saturated soil you can see that it is called as a 3-phase system. Now, the same thing I have represented with what this particular sign convention or this notations will mention. Now, we will go to the completely saturated soil. As you can see, complete voids are filled with the water, which means especially this kind of thing we can see in rainy seasons. Okay, if you take a soil, complete voids will be, in most of the cases, complete voids will be filled with the water. We don't have volume of air. And this is called as a completely saturated soil. The diagram reduces to 2-phase system. Similarly, in the case of completely dry soil also, complete voids will be filled with the air. So, again it is reduced to 2-phase system. Now, we will see some of the basic relations based on this 3-phase as well as a 2-phase diagram. The first one is void ratio, and it is represented as E. Void ratio E is nothing but ratio of volume of voids to the volume of solids. As we know, volume of voids is nothing but volume of air plus volume of water. So, this void ratio represent how much voids present in a particular given soil. Higher the void ratio, it indicates higher the voids in the soil. Similarly, lower the void ratio indicates the soil is dense. For example, if we have higher void ratio, the good example what I can give is a sand, where sand is a porous material. Okay, there are number of voids in that. If you give some water, put some water on this particular sand, it will easily move to other side. Have next porosity, and it is represented by N, where porosity equal to is the ratio of volume of voids to the total volume, and usually it is represented in percentage, so it is multiplied with the 100. And again, if the material is highly porous, indicates all the intermolecules of the soil are arranged far away, or the voids are higher, volume of voids are higher. Similarly, if porosity is less, it indicates complete voids are filled either with the solid particle, in this particular case of low porous material. And usually this ranges from 0 to 100%. And degree of saturation is defined as the ratio of volume of water to the volume of voids multiplied by 100. So, it is represented in terms of a percentage. Again, degree of saturation ranges from 0 to 100%, and it tells how much volume of water present in a particular given volume of a soil solids. And as you can see, in the case of a fully saturated soil, complete voids filled with only with the water. So, volume of water divided by volume of voids, which means volume of water is a full divided by complete volume of voids is filled with the water itself, and value of S will become equal to 1. And similarly, in the case of dry soil, complete voids are filled with air. So, volume of water is 0, and since for dry soil, degree of saturation S will be equal to 0. And in connection with that, one more definition, air content. Air content is nothing but volume of air divided by volume of water into 100, it is also represented in terms of a percentage. And as I mentioned, for complete fully saturated soil, the value of S will be equal to 1 in such a case as air content. Okay, VA divided by VV, VA will be 0, air content will be 0. So, S plus AC, this relation holds good. Okay, S, that is degree of saturation plus air content will gives value 1. Similarly, in the case of complete dry soil, S will be 0, air content will be 1. In the case of partially saturated soil, we will be having both S and AC values. A percentage of air watts represented as Na, it is defined as a ratio of volume of air to the total volume multiplied by 100, and it is represented in terms of a percentage, and always so called percentage of air watts will be less than air content. And one more very important definition, that is water content, and it is defined as ratio of weight of water to the weight of solids. In most of the civil engineering or concerned to structures or analysis of a soil, water content is an important parameter, and usually in the laboratory, water content of a given soil will be found using oven method. And coming to the bulk unit weight, is another very important aspect concerned to soil engineering, and is defined as total weight divided by volume. It is a bulk density. And similarly, in the field we can find a bulk density using some of the tests such as core cutter method. And unit weight of water, that is represented as a gamma D, it is a weight of water divided by volume of water. And we have unit weight of soil solids, is represented as a gamma S, that is weight of soil solids divided by volume of soil solids. And saturated unit weight, and as you know, it is represented as gamma sat, which is equal to W, total weight of the solids divided by volume of solids, and it is a completely in saturated condition. And for all those bulk unit weight of water, unit weight of soil solids, saturated unit weight, the unit of this will be kilonewton per meter cube or Newton per meter cube. Okay. In next session, we will discuss regarding the laboratory procedures to find out these quantities. Thank you.